Alright guys, here we go, number 12. So in this question, solutions based entirely on graphical or numerical methods are not acceptable. So what does this tell us? This means that we cannot put this equation in the calculator and get some results for x, because this will defeat the purpose of what we're trying to do here. So we have to do this using a written method, yeah? So unfortunately, the only thing you can put in your calculator is literally subtracting a few things, but you can't actually solve this. So let's have a look now. 1. Solve for the following range for x, this equation here, giving you answers in degrees to 1 dp. Right, one more thing I also want to add. Every time you got a sine or cos or whatever and you got a really weird equation inside the angle bit, always replace it with y or another letter. So in this case, we now have 5 sine y plus 2 equals 0. Okay, so this doesn't look as bad as previous. Now, what do we do from here? Well, let's go ahead and find the value of sine y, yeah? So what we could do is subtract 2 across and divide by 5. We're going to have an equation which is sine y equals minus 2 over 5. Okay, oops. So minus 2 over 5. Now, this one looks straightforward. To find the value y, we're just going to sine inverse, yeah? So sine inversing this, you should get minus 23.6 degrees. Now, there's a problem here. Notice how this equation here, when you convert it back to x, doesn't fit within the usual range, yeah? And notice how the value is negative. Well, this is where we're going to use something known as the cast diagram, yeah? So let's try this out. So cast diagram means you're going to put CAST, where C, S, and T is cosine and tan, and A means all. Now, because our result is negative, usually if it was positive, we'd use S for sine and A. So A is always used for positive results. Because we've got negative results, we're not going to use sine or A. We're going to use C and T. Now, let's go ahead and fill this up with some values, yeah? So it tells us that the angle is minus 23.6. We always start from here, so this is our origin. So we're going to go down by 23.6 degrees. And because we're dealing with tan, we're also going to write 23.6 degrees. Okay? Now, from here, we can actually work out the positive values of y. So let's do it. So starting from here, we're just going to draw a nice curve smashing into here. And we'll draw another one going all the way around, hitting this line. So this means that we're going to travel, for the first one, 180 across plus 23.6, or 180 plus 23.6. So this is solutions for y, yeah? And we're going to have another solution which is almost a full circle, so almost 360, but it's 23.6 less. So it'll be 360 minus 23.6. And these results are going to give us exactly 203.6 and 271.4 each. Okay, so we're actually pretty much done here. Now, just remember, this is the values for y, yeah? And we said here, let y equal x plus 65. Okay, so let me recap. Y equals x plus 65. So therefore, x is going to be y minus 65. So what we're going to do here, to get x values, we're going to subtract both of these now by 65. And doing so, you're finally going to get 138.6 degrees and 271.4 degrees. And that's it, guys. You've literally got every value in the range for part 1. Okay, part 2. So now we need to find for this new range all the solutions for this equation, giving you answers now in radians to 360 fixed. Okay, so same rule applies, yeah? So first things first, let's switch our calculator from degree to radian mode, yeah? And we won't make that mistake. And by the way, guys, 2 pi is equal to 360 degrees as well. So let's do this. Now, in order to solve an equation like this to find solutions, we have to always solve in either sines or coses or tans, not when they're mixed up like sine and cos. Now, the only way to get them all in the same form is by just recalling some identities, yeah? So we have 2 identities we need to try and memorize. The first one is the sine squared plus cos squared theta equal to 1. So this is when you have squared equations, yeah? The second identity would be tan theta equals sine theta over cos theta. Now just looking back at what we have, we ain't got no tan. So we're not going to use this one, so that's for sure. The first identity is good. Why? Is because we can rewrite the sine squared expression in terms of cos squared, and that's it. Then we have an equation in terms of cos. So let's try it out, yeah? So what we could do, let's go ahead and let sine squared be the subject here. So subtracting cos squared across, we're going to have something like this. 1 minus cos squared theta equals sine squared theta. So replacing this sine squared with 1 minus cos squared, our new equation is going to look like this. So 12 times, 1 minus cos squared theta. What do we have now? Plus cos theta equals 6. Plus cos theta equals 6. All right. So let's see what's next. So now let's go ahead and expand the bracket. We're going to have 12 minus 12 times cos squared theta plus cos theta equals 6. So now let's go ahead and tidy up this expression, yeah? And by the way, guys, I don't know if you noticed it, but we have a squared expression, a regular expression, and some numbers. So this is going to be a quadratic equation, yeah? So this is the form we want. And when we have a quadratic equation, this means we're going to get two solutions for cos theta. So just think of the cos theta as x, okay? That's literally the best way to think about it. Now, yeah, so let's try and simplify this law, yeah? So we're going to minus 6 across, so we're going to have 6 minus 12 cos squared theta plus cos theta equals 0. Good. And I like to make my squared expressions first. So I'm going to move everything to the right, starting with 12 cos squared, yeah? So we're going to have 12 cos squared theta minus cos theta, and then minus 6 across, minus 6. And it should now be equal to 0 again. That's it. So how do we solve this one? Well, again, this is a quadratic equation. So let's use a quadratic formula. So the quadratic formula is a bit like this, yes? We're going to say, all right, cos theta under the quadratic formula is going to equal minus b plus minus square root of b squared minus 4ac over 2a. All right, where a is the value in front of cos squared, so 12, b is the middle one, minus 1, and c is minus 6. And then when you put this in a calculator, I'm not gonna do this here because you just substitute in. You should get two solutions, yeah? So with the plus and minus result, you'll get either minus 2/3 or what did I also get? 3/4. Okay, so I checked this with the solution anyway, guys, and it all lines up nicely. So when you get this result, now we can finally solve this problem, yeah? So we're almost done, yeah? The 6 mark is almost done. So now all we're going to do is inverse both of them, yeah? So if you inverse the first one, cos inverse minus 2/3 in radians, you should get an angle of 2.30 radians. Or if you cos inverse 3/4, you're going to get an angle of 0.723. So both of these need to be 3 sig figs, yeah? Now, we have to ask ourselves, is there any more solutions for both of them? Well, we're going to use a cast diagram. So let's just do a cast for this one and a cast for that one, where we have CAST, again, CAST. Because we're working with cos and it's positive results, we're going to use the C's, and we're going to use the A because A only works with positive values, with positive outcomes, yeah? And then we just labeled the angles. So on this side, we're going to have an angle of 2.30, and again 2.30. On the right side, we're going to have the angles of 0.723 and 0.723. And then now we're going to finally solve this here. So we always start from the origin. So this is the origin here. We're going to just stretch the angle across, so it's going to go hitting this line, but we got that already. It's 230. Our second one's going to go all the way around and hit this line here, which is almost a full circle. And remember, a full circle is 360 degrees or 2 pi. So our other result is also going to be 2 pi minus 2.30. And again, same thing applies to the right side. We're going to have 2 pi minus 0.723. So same thing applies, yeah? And then that's it. Just put this in your calculator and you're going to have two results. The first one being 3.98 and the second one being 5.56. And then collect all your solutions. So you say, therefore, our four solutions is 2.30, this one, that one, and that one. Okay, number 13. So the point A lies on circle C with center O, which is the origin, and radius R. Find the exact value of R. Okay, so very straightforward, to the point. So we're dealing with a circle, right? For these kind of questions, and I'm going to involve A and part B, which is find the equation of a circle. The best thing you should do is always write down the equation of a circle first, the general form. So the general form is always x minus a all squared plus y minus b all squared equals the radius squared, where a and b are the center of the circle, yeah? Center of circle, C. Now, let's have a look. So what do we know about this circle? Well, first things first, we know there's a point that lies on that circle. So x is 9 and b is minus 13. And then the origin, the center of the circle is the origin. So a and b must be 0. So let's just update this equation, yeah? I'm just going to change a and b to 0. So in that case, you're going to have x minus 0 squared, which is x squared, plus y squared equals the radius squared. So for part A, find the exact value of r. Let's plug in point A into this equation, yeah? So A. So we say at point A, we're going to now have x, which is 9, and b, which is minus 13. X, which is 9 squared, plus y, which is minus 13 squared. And it's now going to equal... what's that going to equal? And that's going to equal r squared. So basically, to solve r, literally put this in your calculator and then square root to find r, and your answer should be 5 root 10. Yeah, that's it. Straightforward. And for b, it follows on. Find the equation of a circle. So we have equation of circle. It's right here. R is 5 root 10. If you square it, your equation is now going to be x squared plus y squared equals 5 root 10 squared. I think it's 250. Yep, 250. And that's it. That's A and B done. Okay, next two parts. So a straight line through point A has equation 2y plus 3x equals k. All right, where k is a constant. Okay, so this is 1 mark. Find the value of k. All right, this is easy. So you got A, which passes through this point, and that equals k. Well, all you got to do is literally substitute the value of A into this equation. So replacing x with 9 and y with minus 13, you should get 2 times minus 13 plus 3 times the x, which is 9, equals k. Putting this in your calculator, you're done. You should get a solution of 1. So k equals 1. This straight line now cuts the circle again at point B. Okay, so remember, in the beginning, it cut the straight line cut through point A. And because it's a circle, that only makes logical sense. Imagine this was a circle and this is your straight line. Okay, you know, let's not do that. So you go center, or ignore the center. It cuts at one point A, which we already know, and it also cuts at the other side, which is B. It could be a different shape, but this is just an example. So our question is now, how can we relate the line and the curve together, the line and circle together? Well, when something passes through another equation, we use simultaneous equation. So that's how it is. So we're going to match them together. So let's rewrite the equation of a circle here. It was x squared plus y squared equals 250. And the equation of a line, which we just obtained, which was 2y plus 3x equals 1. Okay, so now all you want to do is literally put this into the circle equation. So what I would do is, let's say, make y the subject. So from here, to make y the subject, I could minus 3x across and divide by 2. This can give us y equals 1 over 2 minus 3x over 2. Nice and easy. And now I'm going to substitute this into the first equation. So let me just go down a bit. So this is going to give us x squared plus bracket half minus 3x over 2 all squared equals 250. Okay, so now this is where the long thing happens, yeah? So we're going to try and carefully expand this, yeah? Just remember, when you got a squared bracket, it means there's 2 brackets, yeah? So just to be clear, it looks a bit like this. X squared plus bracket half minus 3x over 2 times half minus 3x over 2 equals 250. In the end, when you finally evaluate this, you're going to get a quadratic equation, yeah? So let's go ahead and open this up, yeah? So you're going to get x squared plus half times half is a quarter. Half times minus 3x over 2 gives you minus 3x over 4. You're going to get the same thing here, minus 3x over 4. And lastly, minus 3x over 2 times itself will give us a positive 9x squared over 4. equals 250. Now all we have to do is just collect the like terms, yeah? So let's start step by step. So you got x squared plus 9 over 4x squared. I just combined it and called it, so this is like 1x squared plus that. This can give you 3.25 x squared. I'm keeping it in decimal form, yeah? Now for the x terms, you got minus 3x over 4, minus 3x over 4. In the calculator, this will give you minus 6 over 4, will give you 1.5x. And lastly, you got a quarter and you got 250 on the side. Let's make it equal to 0, yeah? So we're going to subtract 250 across, so it goes on the left. And you should get minus 249.75. You might get something similar or, you know, like smaller. If it's proportion the same, then it's all good. But at this stage, we're going to keep it as it is, yeah? So now what we're going to do, to find the value of x, as this is a quadratic equation, we have to use a quadratic formula. So we're going to have x equals minus b plus minus the square root of b squared minus 4ac. You probably notice that we use this formula a lot. And that's actually true. Because you've got a calculator, you can easily solve this with no problem. Where a equals 3.25, b is minus 1.5, and c is minus 249.75. When you put this in a calculator, please use brackets for every letter. Like for instance, for minus b, I would write minus bracket minus 1.5. There's no point taking a risk, even if you know it's positive. Your calculator will instantly like recognize it, yeah? But anyway, when you do this, you should get two results. The first one, which is trivial, you're going to get x equals 9 when you plus it. And that matches the coordinate of a. Because if you remember, at point A, we know the x coordinate is 9. So when you plug in 9 into any equation, into the circle of the curve, you can end up with y equals minus 13, which is at point A. Now, if you put the negative value, you're going to get x equals this kind of weird fraction, minus 111 over 13. And when you plug this into any equation you got, so in this case, let's see, I decided to plug into here. You could also plug into here, but then you have to make y the subject, which is unnecessary. So replacing x with that fraction we just got, and you should definitely get something that says, let's see, what was that, plus 173 over 13. I want you guys to check if this one's the same, yeah? I'm pretty sure it is, but have a look and let me know, guys, yeah? But other than that, I hope this video helped, and I'll see you guys in the next one. Take care.